Okay, so this is just a quick review for sections 4.5 to 4.7 for the quiz. So we're just going to make sure that you understand some things about the equations of graphs of trig functions, how to put them in your calculator, manipulating the equations, that sort of thing. So first I'm going to draw a sketch of y equals 3 cosine x. Before you draw the picture, you always want to find the amplitude and the period of the equation. So the amplitude of this function is going to be 3 because of the 3 in front of the cosine x. So that tells me that this graph is going to go up to 3 and down to -3. Then you want to find the period of the function. So you're going to take 2 pi and divide it by the number in front of x, which is a 1. So 2 pi divided by 1 is just 2 pi. So that tells me how far to the right I'm going to go on my graph. So when I start drawing the graph of this function, I'm going to draw my x and y axis. The last number that I'm going to label on the x-axis is going to be my period, which is 2 pi. And remember, we always split it up into 4 equal pieces. And then up and down, I've graphed 3 points. Remember that when you graph the graph of cosine, you start at the amplitude, to the axis, negative amplitude, axis, and then back up to the positive amplitude. So this is what the graph of 3 cosine x should look like. So if you're going to set your window in your calculator, remember your x's is going to go from 0 to 2 pi, and then for your x scale, you're going to do whatever your period is divided by 4. So 2 pi divided by 4, which would wind up being pi over 2. So that would put a tick mark every 4 spaces like you see here. And then your y's, it doesn't matter what you make those, you at least need to go to 3 and -3 for the y-axis. Okay, so that's the graph of 3 cosine x. Alright, so on this second problem it says what is the amplitude and period. So I need to be able to look at an equation and determine what the amplitude and period of the graph would be. So first thing you're going to do for the amplitude, it's always the number in front of sine or cosine. So that's going to be 3 over 4. So this graph would go up to 3 over 4 and down to 3 over 4. Then we do the period of the graph. The period is always going to be 2 pi divided by the number in front of x, which is a 2. So for the period, we're going to do 2 pi divided by 2. So 2 pi divided by 2 is just going to simplify to pi. So the period for this function is just going to be to pi. So if I was going to graph it on my x scale or on my x-axis, I would go from 0 to pi, and then my x scale, I would do pi divided by 4, or pi over 4. And then on my y's, I would make it go up to 3/4 and down to -3/4. Okay, so a problem like this, inverse cosine of square root of 2. So when you type these things in your calculator, make sure you're paying attention if the directions say degrees or radians. This one doesn't say, so it really doesn't matter what mode you're in. What this question is asking is, what angle has a cosine of the square root of 2? So when you type this in your calculator, you're actually going to get something weird. It's going to say error, domain. Okay, don't freak out if you get an error. For this situation, that just means that there is not a value where cosine is the square root of 2. There's no angle where cosine has a square root of 2. So it just means that there's no value or it's undefined. Okay? Otherwise, as long as you type it in correctly, you're going to get the correct answer. Okay, the next one, we've got a picture of a graph, and I want to know what the amplitude and period is just by looking at the graph. So remember, amplitude is half the height. So if you look at this graph, it goes up to 3 and down to -3. So that means the amplitude is going to be 3. The next thing would be the period. The period is how often does this graph repeat? Is it the same thing over and over? So if you want to just pick a point somewhere on the graph and then see, okay, how long does it take on the x-axis for it to do that again or for it to restart? So if you start at 0, it's up at 3, and if you trace the graph along, the next time it's up at 3 is at 4 pi. So every 4 pi spaces, this graph is going to repeat. So that means that the period is going to be 4 pi. Okay, next problem says cosine of tangent inverse of the square root of 3. So this is like the triangle problems that we did from section 7. So I would start by drawing a triangle and labeling the parts that you're given. So I kind of jumped ahead here. But the tangent would mean that the opposite side would be the square root of 3 and the adjacent side would be 1. Then you would use Pythagorean theorem to solve for the missing side, which turns out to be 2. Once you have your triangle drawn from what's inside the parentheses, then we're trying to find the cosine of that triangle. Cosine is adjacent over hypotenuse, so that turns out to be 1 over 2. On this type of problem, you could also use your unit circle. If you find an angle where the tangent is the square root of 3, and then look at the cosine of that angle, it's going to be 1/2. Okay, and there would be 2 places on the unit circle probably where this would be true. Okay, next if I look at the graph of 2 cosecant of 3x, you want to kind of start this one the same way that you would for sine or cosine, in that you need a period and an amplitude first to determine how far your graph needs to go and in what directions. So the amplitude of this graph is 2, so that means it's going to go up to 2, down to 2. The period is going to be 2 pi over 3. This is the same way you would do it for sine or cosine. So I'm going to use this to help me start my graph, and I'm actually going to graph the sine function using this information, and then I'll use that to graph the cosecant. Okay, sorry, pushing a few extra buttons here. Okay, so if I draw my graph, and I'm going to go out to 2 pi over 3, and remember, divide it up into 4 equal pieces. You don't necessarily have to know what those pieces are, but you could actually figure that out just by dividing it into 4 equal pieces. And then I need to go up to 2 and down to -2. And I'm going to put the sine graph on here, but I'm just going to do it with a dotted line. So the sine starts at the origin, goes up to the amplitude, back to the axis, negative amplitude, back to the axis. So I'm going to do some dotted lines in here. So that's what the sine function would look like. But cosecant is the reciprocal of the sine function. So everywhere the sine function touches the x-axis, you're going to draw an asymptote. Okay, and then everywhere that you see the points floating out in between those asymptotes is where you're going to draw your u's. So in the first section of the graph, the u is going to be going up because the point is up. In the second section, the u is going to be going down. Okay, so the green lines are actually the graph of the cosecant function, okay, and the asymptotes. When you're drawing a cosecant or a secant or a cotangent, make sure you draw in those asymptotes. Okay, next if I look at something like this, cosine inverse of cosine of 2x. We learned in section 7 that the inverse function is like the opposite operation of a trig function. So cosine inverse and cosine cancel each other out. So I can cancel those out and you're left with whatever is on the inside. So this is just actually equal to 2x. Okay, last one here, I want to give the exact value. It says arctangent of negative square root of 3 over 3. Arctangent, remember, is the same thing as inverse tangent. So this means what angle does tangent have a value of negative square root of 3 over 3? So this is where you could use your unit circle, and you're just finding out what angles tangent has negative square root of 3 over 3. Now, you could type this into your calculator, but it's not going to necessarily give you the correct angle because we want it in terms of radians. We don't want it in degrees. If I was in degree mode, I might get a degree answer, but I want a radian answer. Okay? So when you look on your unit circle and you try to find where tangent is negative square root of 3 over 3, remember that tangent is going to be negative in quadrant 2 and in quadrant 4. So when I'm looking in those two quadrants, turns out the two angles that we're looking at is 5 pi over 6 and 11 pi over 6. Okay, so if you just type this in your calculator, it's going to give you some crazy decimal answer. You're not going to be able to change it back to something that's a radian. So you need to be able to look at your unit circle and find the information on it.